Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 27 of the December daily LeetCode challenge. We are dealing with some of the last questions in this 2024, and we again have a question which is medium. So yesterday also we had a question on DP, and today also we are having a question which can be solved using DP and many other multiple approaches. Okay, so we'll be seeing some of the most optimal approaches for this question. So this is 1014 best sightseeing pair. Let us see what it is. You are given a integer array called values and you have written integer as the output. Okay. Now let's see what is the question. So you are given an integer array values where values of I represents the value of the ith sightseeing spot. Two sightseeing spots I and j have the distance j minus I between them. That is, if you are considering two spots, let's say this one and this one, so the difference between them is going to be the difference between their indexes. Okay, simple as that. The score of a pair, remember till now we are only dealing with a single index. Okay, for a single index the value is going to be values of I. Okay, now they're talking about a pair, so let's see what they're saying. The score of a pair, okay, where the pair is going to I and j, where I has to be less than j, of sightseeing spots is, they are writing this. What is that? The that is the values of those indices plus the difference between those indices. Okay, that is the distance between those indices. Okay, that is the sum of the values of the sightseeing spots minus the distance between them. Okay, I hope you are clear with this part. Let me tell you this again, what is happening. See, in this is the the actual definition in words. What is that? Sum of the values of the sightseeing spots, that is values of I plus values of j. Remember, what is the pair? The pair is I comma j. So what is the value is going to be? The value of that is yep, they are saying the score. Okay, what is the score going to be? The score is going to be the sum of the values of the root two indices. Okay, so values of I plus values of j, then they are saying minus the distance between them. So what is the distance between them? This is the one. Okay, that means you have to write values of I plus values of j minus this particular term. Okay, so then if you bring the minus, it is minus j minus I. Now if you solve it further, what you will get? You will get plus I and minus j, and that is what they have written. This is the simplified version of that. Okay, as simple as that. So anyway, like whatever be the thing, this is the ultimate thing that we'll have to use. Okay, this is the one that we'll have to use, and this is the one that we'll have to optimize. So now they're saying return the maximum score of a pair of sightseeing spots. So among all this, you will have to form is two pairs. Okay, in that, let's say I and j are the pairs. I has to be less than j. Then you will have to use this formula to get your answer. Okay, one more thing, since I and j both are involved. So yeah, as you can see, I and j both are involved. So see here, there it has to be plus I and minus j. So how you have to know which one you have to do plus and which one you have to do minus? Always, if you have to see among the two, always one of them will be smaller, one of them will be bigger. Okay, so I has to be smaller than j, and so on. Okay, so the one which is smaller will be added, and the one which is greater will be subtracted. Okay, that is the basic idea here. After that, let us see some examples. Okay, you can go through the example, but idea is very simple. I hope so. So if you see here, yeah, they are giving you these points. So yep, they are saying these are the two pairs. Okay, if you take I equal to 0 and I equal to 2, you're if you and then calculate this particular value, this is going to be the most optimal value. That is the maximum value possible. That is the question. Return the maximum score of a pair of sightseeing spots. Okay, so that is what they are telling. Now let us come to understanding what is the algorithm going to be. Okay, if you see the constraints, it is going to be around. Okay, just a second. Yeah, it is going to be in the range of 10 power 4. Okay, 5 into 10 power 4. Okay, the length is going to be values as such do not make a sense to me, because yeah, in this question doesn't make sense, but the length of the input will matter, which is in the range of 10 power 4. Okay, now one thing is very clear. See, in the brute force, if you have to do, what you have to do, see, for every I you will search for the every other j. Okay, that is for every single index here, you will try to make it a pair with any of the available indices. Okay, as simple as that. Since j has to be greater than I, that means you will run something like this. So for this I, you will test for all these j's. Similarly, for this I, you will test for all these j's. Similarly, for this particular I, you will test for all these j's, and so on. Okay, similarly you can do that. So that will take around O of n square time. Okay, but seeing the constraint is very clear that you will never be able to clear this kind of length, this much length of input with the O of n square solution. So we have to think for something linear here. Okay, either O of n or O of n log n or something similar. So first of all, let us try to see what is being done here. Remember, this is the formula which they have given, something which we have not derived. Okay, remember that part. It's a very big hint actually. Whenever you are given a formula, okay, in any lead coding problem, always remember there is some hint there. Okay, because remember, this is not something logical, or this is not something that we are bringing to solve this question. This already given. So let us try to optimize what we can do here. Okay, I'm just writing this here for your reference. This is what they have given. Okay, now I'm just rewriting the terms, something like this. Okay, let me first remove the comment symbol. Yes, now it will look fine. So if you see, this is the one given to us. Now I'm just trying to rearrange it. Okay, how it will be, I'm just arranging the terms related to I. So it is values of I plus values, That's values of I plus I plus values of j minus j. Okay. So, but you have to, one thing you have to ensure is I has to be less than j. Now, can you quickly tell me what you understood with this? That is, for every j, you just need, for example, just take example here. For example, I am at j. This is the j for me, right? This is the j for me. Now, anything, all the integers which are prior to this, among them we'll have to find the max this value. Okay, the max value of this for I which is present among this. Okay, so that is the what I've written. Okay, given I is less than j. Okay, so for idea here is for every j. Okay, see, when you are at a j, obviously you are going to get this value, right? This value is not going to be a fixed one. Okay, this is going to be variable. For a particular j, you can hold this thing as a constant. Then all the indexes which are prior to this j, among them you have to find this particular value, whichever value gives the max. Okay, for example, whichever I give the max value of this for a particular j, okay, then we'll have to take that value, and that could be one of the possible answers. Okay, for example, I'm just giving an example. For example, if j is equal to, let us say here, index 2. Okay, what is the index 2 value? Index 2 value is value for that is going to be 5. Okay, I'm talking about example 1. Okay, fine. Now, since j is 2, what are the options you have? You have the option of I is equal to 0. You have the option of I is equal to 1. Okay, these are the two options that you are having. Okay, now, among them, for each one of them, you have to calculate this particular stuff. Okay, this particular term you will have to calculate. For I equal to 1, also you will have to calculate this term. So, among them, whichever gives the maximum value, okay, among these two, whichever gives the maximum value for this term, that we will have to take for j equal to 2, and j equal to 2 means I am talking about this term. Then that is going to be one of the possible answers. Okay, then the value that you are going to get is going to be one of the possible answers. Okay, so I'm just writing this for your reference. Now, what we have to do now? So I will just show you the solution now. What solution I'm going to show is going to O of n square, O of n approach. Okay, that is it. So first of all, what I'm doing, see, this is the term which I'm calling as max value of I, and this is the term I'm calling as max value of j, because they are dependent, they are dependent on j. So just for a namesake, I'm giving this the name. Okay, so initially, just remember one thing: the always j has to be greater than I. Okay, do you agree with me in that? So for that reason, I cannot be 0. Okay, sorry, j cannot be 0. That is, j can never be the 0th index. Okay, because there is no index prior to that. Okay, for that reason, the value that I'm going to calculate will be on the 0th index. Okay, so max value of I is going to be like this. Okay, max value of I is going to be value of 0 plus 0. Why I'm writing plus 0? Just for your convenience. Okay, so because this is the formula, right? Just to match this formula, I'm writing exactly as it is. Okay, values of 0 plus 0. Okay, fine. Now, this particular thing whatever you're seeing here is going to start from 1. Okay, 1 to n. Okay, so here we are going to calculate, that is for each index I. For each index I, what we are going to calculate, first of all we are going to calculate max value of j. Okay, that is this particular term I am going to calculate now. Okay, max value of j. So max value of j is going to be values of I minus I. Okay, this exact formula that I'm going to use now. Okay, this is the exact formula. Okay, values of I minus I. Now, what I'm going to do, answer is equal to this, right? Answer is equal to this plus this. Okay, so that was what we are going to do. Answer is equal to max value of I plus max value of j. That's what I'm going to calculate. I'm going to take the max value of this thing, comma, any previous answer that we have seen. Okay, I'm starting the answer with 0, as simple as that. That I will storing it my answer. Now, once this index is done, that is, once I have evaluated this particular value, then this particular index I can also be considered for this value. Okay, simple as that. Now I'm going to calculate the max of this also. See, this is the max value of j. Now I'm going to calculate the max value of I for the next indices. Okay, so max value of I is equal to max of the previous max value of I, comma, the values of I plus I, that is this particular term. Okay, this is the one that I'm talking about, this particular term. I'm going to calculate that now, and then this will be carried forward to all the next iterations. Okay, let me quickly run this and show it to you. As you can see, this clearing all the test cases and already segmented this solution. So this was the Python solution. Let me come to the Java solution also. Java also we are doing exactly same thing, and since there is no data structure involved, this is going to look pretty simple. Okay, this is exactly same thing. I've kept the names also same for your convenience. Okay, exactly same. So the max value of I initially is going to be the 0th value. That is, yeah, what I've shown you here. This is the one. Okay, then we are starting from 1 till n minus 1. Why like that? Because if you see, j can start from 1 to n minus 1. Okay, for that reason I'm starting from 1. Okay, next I'm calculating max value of j using this particular formula. This is coming from this. Okay, this coming from this. Now for each value of this, for all the prior indices, I'm going to calculate the max value of this. For that reason, I'm using this. Yeah, this is the one, max value of I. So the previous max value of I, for all the indices which are prior to that, this is going to keep the max value. Okay, plus the max value of j, and this is going to be my answer. Okay, next we are going to update this also. For that, what we are doing, max value of I, comma, values of I plus I. Okay, simple as that. and then we're writing the answer. And let me submit this and show it to you. This is also clearing all the test cases. Okay, so this is going to be O of an approach in terms of type complexity. In terms of space complexity, it is going to O of 1. Okay, if you see in both Java and Python, we are just doing some constants here. Okay, that is, they are just variables. Okay, they are not arrays or something like that. They are just constant. They are not dependent on n. Okay, that is the most important part. That is why we will be calling that as O of 1, or that is O of constant solution. So yeah, that was all for this video. I can give the solution to you. Okay, take it, try to understand what is happening. I'm damn sure you will be able to do it. I don't want to spoon feed this content to you, because this, you will have to understand what is happening. Okay, this is going to be on the easier side. Here only the idea was important. Once you get the idea how it is working and all, I am sure that I have given you all possible explanation. But still, if you have not understood, I am expecting you to take pen and paper and understand what is happening. Okay, this is not hard. That's why I'm leaving it on you. If you have not understood till now, pause this video, take a pen and paper, start writing, and then you will understand what is happening. So often that was all for this video. We are done with day 27 of the December daily LeetCode challenge. See you tomorrow. If you like my contents, please subscribe. This really gives a lot of motivation to continue further. See you tomorrow.